Okay, so yesterday we stopped at IP address,
Yep.
right? So in IP address we're having two versions, that is IPv4 and IPv6.
Yep.
IPv4 is a 32-bit address which is represented in dotted decimal format, or simply you can say decimal format, whereas
Mm-hmm.
IPv6 is 128-bit address represented in colon hexadecimal format, or you can say
Mm-hmm.
hexadecimal format. Now here we are discussing
Yep.
about IPv4. Now we are discussing
Mm-hmm.
about IPv4. This
Yep.
IPv4, which is a 32-bit address divided into 4 octets. This IPv4 is divided into 4 octets. Each
Mm-hmm.
octet contains 8 bits. Each octet contains 8 bits, and each octet
Mm-hmm.
is separated by a dot.
Yep.
Each octet is separated by a dot. Now, what is a bit?
Mm-hmm.
Bit means in computer language it is binary number 0 or 1. Bit means
Yep.
0 or 1. So if you write an IP address in binary format, the address will look like this: dot dot dot. So this is first octet, second octet,
Yep.
third octet, and fourth octet.
Mm-hmm.
This is how an IP address is represented in binary format. But for our convenience, we write this IP address in decimal format. Example,
Yep.
172.16.0.250. This is an example of an IP address in decimal format. First octet,
Mm-hmm.
second octet, third octet, and fourth octet.
Yep.
Now in binary, you having only two bits, two digits, that is 0 and 1. 0 being minimum and 1 being maximum. Now if
Yep.
I keep all the bits in an IP address as zeros, 0, 0, 0, 0, like this, if I keep all the bits as zeros,
Mm-hmm.
when you convert this IP address into decimal format, it will be 0 dot 0 dot 0 dot
Zero.
0. Now if
Yep.
you have the maximum number, that is if you have ones, so when you convert this binary value into decimal value, it
Two
will
five five.
be, yes, 255 dot 255 dot 255 dot 255. So 255 dot 255 dot 255 dot 255. That is the
Mm-hmm.
maximum range.
Yep.
So the range of IP address is 0.0.0.0 to 255.255.255.255.
Yep.
This is the range of the IP address. Now this range is divided into 5 classes: class A, class B, class C, class D, and class E. Each class is having its own range. Class
Yep.
A's starting IP is 0.0.0.0 and IP is 127.255.255.255. Class B range is 128.0.0.0 191.55.255.255.
Yep.
Class C 192.0.0.0 to 223.255.255.255. Class D 224.0.0.02 to 39.255.255.255. Class E 240.0.0.02 to 55.255.255.255. So these are the ranges for the classes.
Yep.
Okay. Now, how do we get these ranges? How do we get these ranges? It's based on priority bit. Why class A should end with 127 or why class C should start with 192. The ranges we get based on the priority bit. Now, what is this priority bit?
Okay.
A priority bit is the leftmost bit of the first octet. It is the leftmost bit of the first octet. Now, how can I get this priority bit? For this, there is a committee called as ICANN. A committee called as ICANN that has given a standard for priority bits. This is a committee that gives standards, rules, regulations related to the IP address. International Committee for Assigning Names and Numbers. International Committee for Assigning Names and Numbers. So what it said is, if it is a class A IP address, the priority bit is 0. If it is class B IP address, the priority bit is 10. Class C 110. Class D 1110. Class E it is 1111. So these are the priority bits for each class. Now let's see. Take all bits as zeros here. I'm taking example for class C. Take all bits as zeros. Leftmost bit of the first octet. This is the first octet. And leftmost bit. So here for class C we had taken 3 bits. So here in 3 bits we have to change it to 110. Now convert this value. Convert this value into binary. 2 power 7 plus 2 power 6. It is 128 plus 64.
Yep.
It will be equal to 192.
Yep.
Right?
Yep.
The remaining are zeros. 192.0.0.0.0. Now to get the ending IP address, Without disturbing this priority bit value, the remaining values should be taken as ones. You'll be getting the ending IP.
Yep.
Okay, that's how we get the range of the classes. Now, in these 5 classes, we do not use all the 5 classes for assigning IP address for the system. We use only class A, class B, and class C
Okay.
for assigning IP address. What about class D? It is used for multicasting. What about class E? It is used for broadcasting and research. Broadcasting and research. Now you're having only 3 classes for assigning IP address. Now this IP address part contains 2 things: host ID and network ID. Host ID and network ID. Host ID means it tells about the address of the device. It tells about the address of the device. Network ID tells about in which network the device is. In which network the device is. Now, if you take any IP address, every IP address will be having 4 octets. Every IP address will be in the form of numbers. Now, how can I identify what is the network ID and what is the host ID? What part should I take it as network and what part had to take it as host? We need some identification. This is network, this is host. For that, again, if it is a class A, take the first octet as network and the other 3 octets as host. Class B, take the first 2 octets as network and the other 2 octets as host. Class C, take the first 3 octets as network and the last octet as host.
Yeah.
Okay. Now it means if you are having any IP address like this, so if you're having any IP address like this, we need to identify which class it belongs to. First, we need to identify which class it belongs to. To identify which class it belongs to, first we need to know the range of the class. What is the range of class A? What is the range of class B and class C? So when we know the ranges, then we can identify which class it belongs to.
Yeah.
Now, when identifying the class, we have to take only the first octet to identify.
Yeah.
Bottle. Okay, we have to take only the first octet to identify the class.
Yeah.
Okay, right. Next. In class A, so in class A, we know that the range is 0.0.0 to 127.255.255.255.
Yeah.
In this range, 0 dot network and 127 dot network is not used to assign as IP address for the system. 0.network and 127.network is not used to assign as IP address for the system. It's because this 0.network is called as universal network address. It is used in special cases in routers, but not for the systems. And this 127.network and this 127.network is called as a loopback adapter. It's called as loopback adapter, and it is used for basic troubleshooting when we are checking the connectivity between two devices to check whether your Ethernet adapter or slot are working or not.
Yeah.
Just a minute. Listen. This notepad has got some problem.
Okay.
Thank you. I'll open up the notepad. Oh, my keyboard has got a problem. Not this.
Okay.
Next, let's say we are having few devices, system A, system B, system C, system D, like that, and we had assigned some IP address like 10.0.0.1 for system A, and for system B 10.0.0.2, system C 10.0.0.3, system D 4. It means we had used 10.network IP address. The network we had taken is 10. In this 10.network IP address, the first IP address, the starting IP address on this network will be 10.0.0.0, all the host bits being zeros. It will be the first IP in this network. And 10.255.255.255, all the host bits being ones, it will be the last IP in this network. Again, these two IP addresses will not be assigned as IP address in system. This first IP address, the starting IP of any network, is used to identify the network, and the last IP address is used for broadcasting. Yesterday we had discussed about this difference between hub and switch.
Yep.
The device is connected to hub or switch. Now this hub or switch will identify the networks of the device based on their starting IP addresses, what network they belong to. And if it has to broadcast any data, it will use that network's last IP address as broadcast address. So the hub or switch will be using this address as broadcast address to broadcast any packet in that network.
Yep.
Okay. So except this, the remaining all the IP addresses will be assigned for the system.
Okay, yeah.
Okay. So this is the same for the other classes also. Okay. Now, how many networks you can have in a class and how many devices we can connect in each network? Number of networks in each class. The formula will be, I will show. Two power number of network bits minus priority bits. 2 power number of network bits minus priority bits. So it means, yeah, here. Okay, 2 power number of network bits minus number of priority bits. For class A, number of network bits, you're having only the first octet as the network ID. Octet means 8 bits. So the number of bits is 8. Number of priority bits, for class A you're taking only 0 as a bit, as priority bit, means only 1 bit. It will be 8 minus 1, 2 power 7 bits. Okay, till now we are discussing octets, number of octets, 1 octet, 2 octets, 3 octets. Here we're discussing in the form of bits, number of bits. So 1 octet is equal to 8 bits, 2 octets 16 bits, 3 octets 24 bits.
Yeah.
Class B, first 2 octets are network bits. 8 plus 8. 16.
Okay.
And priority bit is 1, 0. Means you have taken 2 bits, 1 and 0. 16 minus 2, 2 power 14. We're getting this number of networks. The same case applies to class C. So if you see here, class C is having more number of networks, where class A is having very less number of networks. Now in each network, so these are the number of networks we are having in each class. Now see how many devices we can connect in each network. Number of host bits minus 2. Number of host bits minus 2. These are the number of devices we can connect, 2 power 24 minus 2. So in class A, I can connect around this number of devices in a network. Class B, 2 power 16 minus 2, and class C 2 power 8 minus 2. If you observe, it's reverse. Here if you got 8 means class A for host will be getting 24. Here you got 24 means you will be getting 8. And in class C you can connect less number of devices per network. You can connect less number of devices per network.
Yeah.
Okay. Next, subnet mask. So what is this subnet mask? Subnet mask is used to uh, identify the number of network bits and number of host bits in an IP address. It is used to identify the number of network bits and the number of host bits in a network, in an IP address. We'll be having a default subnet mask which is used to identify the class of the IP address, whether it belongs to class A or class B or class C. The default subnet mask for class A is 255.0.0.0. For class B is 255.255.0.0. Class C is 255.255.255.0. Now if you observe this pattern, network, host,
Yep.
host, host. The network portion is filled with ones and the host portion is filled with zeros. Network, network, host, host. Network, 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 host. So is it not in the same pattern?
Yeah.
Okay, that's the default subnet mask. It identifies the class. So when you give an IP address plus clam, an automatic default subnet mask will be coming that will say which IP address which network it belongs to, which class it belongs to. And apart from this, there are other IP subnet masks that we modify, which tells the number of network bits and number of host bits. Now,
Yeah.
public IP and private IP. So when this IP address concept is first introduced, they had started assigning unique unique addresses for each and every device. They started assigning unique addresses for each and every devices. When they're assigning like this, they came to know that if we go on assigning unique IP addresses for each and every device, we will soon come short of the IP addresses. There will be no address to assign for new devices. So they wanted to preserve
Yep.
the IP address with some sort of any solutions. So they came up with a concept called as natting. They came up with a concept called as natting, where you have 10 IP addresses, 10 systems with 10 IP addresses, but communicating with one IP address. After that, they came up with a concept called as public IP and private IP. For in each class, some range is taken as private IP. In class A, it is 10.0.0.02. 10.255.255.255. In class B, it is 172.16 network to 172.31 network. In class C, it is 192.168.0 network to 192.168.255 network. So these ranges are taken as private IP addresses, which can be used in LAN communication, which can be used for communication within the organization, etc., and which cannot be used for public communication,
Yep.
And for public communication, that is for internet, we use public IP address, and which is commercial, means I have to pay some amount to have this IP address so that I can be able to communicate with public world, not only with my internal organization, but with a public world. I have to pay some amount. That's public IP address. That's the
Yeah.
public IP address. Now next is APIPA. APIPA. APIPA stands for Automatic Private Internet Protocol Address. If my system is not connected to any server, and if I had not assigned any IP address, then an automatic IP address will be assigned to my system. That IP address will be called as APIPA. And the range of that address will be 169.254.0.12, 169.254.255.254. In this range only, you'll be getting some IP address, an automatic IP address assigned by the system. We call it as APIPA. Okay, this is about the IP address. This is about the IP address. IPv4. Now, yes, we will see how to assign IP address, how to check the connectivity, how to change the system name. So here I had already installed the virtual machines. Just a minute. So we'll start those virtual machines. Let's wait till the system starts. It's taking a bit longer than expected.
Okay. Just want to know what you're trying to show us at the moment.
IP address assignment, checking connectivity,
Mm-hmm.
changing system name, and if
Okay.
we are having time, a little bit other topic.
Yeah. Okay.
I should have waited till this first system has started loading
Mm-hmm.
so that it will be faster.
Okay.
As I have started both the systems almost at a time, it became slow.
Mm-hmm. Mm-hmm.
Slower than I had expected.
That's fine.
Okay, this first system has finished loading. We'll wait for the second system also,
Mm-hmm.
so that we will not be having any dragging.
Yeah. So in this IPv6, are we going to use this IPv6 or we just use IPv4?
Yeah, we are talking
Addresses.
about only IPv4. Same like
Okay,
IPv4
but
only, we'll be using IPv6, but the addressing
mm-hmm.
formatting will be different.
Okay.
Okay.
But in general, we use like IPv4, right?
Yes.
Like in everyday basis.
Yes.
Okay.
And in IPv6, we do not have any classes.
Okay, yeah. Do you have what we call index or anything that what classes? I mean, on which topic you're covering?
Okay, the
Are you
topics
going to
we
provide
are
us
going to
anything like
cover.
that? Yeah,
Yes.
just for our reference.
Yes, I will ask the madam to send a copy of that to
Sure.
your mail address or WhatsApp numbers.
Yeah, sure. Thank you.
Okay.
It's better if she send an email. It will be easier for us to have a look.
Yeah, sure.
Thank you. So if we can't make any one day, are you able to manage those class in next classes?
Which one?
If we can't make any one day or something, are you able to manage that class in different sessions?
Yeah, yes,
Just
it's
in
possible.
case.
Yes.
Okay. That's fine.
Load అవుతుంది. 25 అంతే. నేను నీకు ఇస్తాగా. Still loading. Okay, we will try to do on this system. Let's see. Press Windows plus R. Type ncpa.cpl. Just a minute. It usually doesn't take this much of time.
So can we discuss something else apart from this?
Okay.
We wasted like more than 40 minutes, that's why.
Networking models. We're having two networking models. work group, or we can call it as peer-to-peer. And the second one is client server or domain model. Client server or domain model. In work group, let's say you're having a switch or hub to which the devices are connected. Here in this model, you'll not be having any dedicated server to control other devices. Each device is its own administrator. And it doesn't depend on other devices. In this model, from Windows NT onwards, we need an user account to log in. From Windows NT onwards, we need an user account to log in. So it needs to have some database to maintain that users. Which users are present in my system? That database we call it as SAM database, Security Accounts Manager. Security Accounts Manager. In this SAM database, which is present in each and every system, we'll be having information about the user, his password credentials, the type of user, the permissions he is having, everything will be present in that database. So now when a user tries to log in on a system, this SAM database will be checking whether this particular user is present in the database, if the credentials supplied by him are valid or not. The credentials supplied by him are valid or not. If they're valid, then this user will be allowed to log in. Otherwise, he will be rejected.
Yep.
Now let's say you had created the user on this system, but this particular user wants to log in on this system. So when he tries to log in on this system, the SAM database will reject his login because we had not created an user account on the system.
Okay.
This user U1 is present, is already created, then he will be able to log in on the system. It means you can log in only on that system in which you're having the user account. Otherwise, we cannot log in. This is workgroup network. To maintain this workgroup network, I need a basic knowledge of this networking. Assigning IP addresses, checking connectivities, creating users, sharing the files. So if I know very basic knowledge about this networking, I can be able to manage this workgroup network. I do not need any dedicated hardware resources. I do not need any network administrators who's having much more knowledge. Okay. So this is what we have having in this workgroup. The problem is you need to create users in each and every device.
Yeah.
If the user has to login in other system, it means he should be having an account.
Account. Yeah.
But when it comes to a client server model, you'll be having a server. We're having a server which controls the clients connected to it. Now this server will be having a central database.
Mm-hmm.
It will be having a central database which checks the user logon process. Now,
Yeah.
in this model, I create users only once on the server. But those users can log in on any client machine connected to that server. So here we create users once, but they can log in any system.
Mm-hmm. Yeah.
But to maintain this client server model, I need a dedicated network administrator. Basic knowledge of assigning IP addresses, checking connectivity is not sufficient for maintaining this client server or domain model. So I need to know
Mm-hmm.
something else, something more. Sometimes I may need to have dedicated hardware devices. So I need a network administrator, a dedicated network administrator. I may need some hardware resources. Advantages: I create
Mm-hmm.
users only once, but they can log in on any system. And one more
Yeah.
advantage which we are having in this client server model is, in this client server model, we can have centralized and decentralized administration. Whereas in
Mm-hmm.
workgroup model, we cannot have that. For example, if you take an example, as an administrator in workgroup model, I had to move from system to system to sort out the problems. Now, what I will do, I don't want to roam around. I will train the users in solving small problems by themselves. Instead of me going every time, I will train those users who are using who are using the systems in solving little small issues by themselves. Now, to do anything on the system, you need to have the administrative rights. Without administrative rights, you cannot do anything on the system. It means I'll be giving some administrative rights to the users so that they will not bother me every time.
Oh,
In an
you came back now, so
organization,
we can't hear you. Hello.
yeah, hello.
Yeah, I
Yeah,
was
can you
unable
hear
to
me now?
hear you before. Yeah, yeah, yeah.
Okay. Okay. At
So
what
the last
point you had
one
stopped
that I
hearing?
heard is like centralized. You're talking about the centralized and decentralized
Yeah,
one?
centralized administration and decentralized administration. So in a work group environment, as an administrator, I had to roam around to solve the issues or problems, whether small or bigger. Now I don't want to move around. I want to go only if the problem is bigger, if it is critical. So for those small issues, I'll be running the users who are using the systems in solving.
I believe there is some issue with this.
Yes.
Hello?
Yeah.
Yeah, I think there is some issue with this one. I
Oh.
can hear you now again. As soon as I told you, it's gone again. The connection gone again.
Oh. Now you're
Sorry.
able to hear me?
Yeah, yeah, yeah. I can able to hear you now. Yep.
Okay.
Yeah.
So this work group administrator, will be
Hmm?
training the users in resolving small issues. Now, to do whatever you want to do to solve the problems in system, we need to have some administrative rights.
Yep.
Means I had given the user the administrative rights so that they will not bother me in for each and every small issue also. Now,
Mm-hmm.
in an organization, not every person is genuine and honest.
Yeah.
There will be some people who may try to mischief, who may try to misuse the permissions we had given.
Mm-hmm.
Now, they are having administrative rights, they can do whatever they want to do, and there is a chance that they may get the confidential data and go out. It means
Yeah.
we are compromising with the security. We are compromising
Mm.
with the security.
Yeah.
But in client server model, we can do centralized administration, means the administrator will be doing all the things, or he can share his works with others. He can share his work with others
Mm-hmm.
so that he can relax and he can have some other works. He can concentrate on other things without
Yeah.
compromising of security.
Yep.
Okay.
Yep.
Okay. Yeah. Let's see how to assign the IP address for this one system. We'll see the other system tomorrow and connectivity tomorrow.
Yeah.
So
Sure.
Windows R, type ncpa.cpl. Okay. ఇదైతే కావాలా మేడం దగ్గర ఉంది 5:36 అవుతుంది రికార్డింగ్ అయ్యేసరికి వన్ అండ్ అప్పుడు పెట్టేదాను కదా మురకానికి పెట్టేదానుక అంతే ఉంటుంది. ఇది అంతే. This something. That's what you want to do. Yeah. Right click on this Ethernet.
Mm-hmm. So it's on
Properties.
VirtualBox, right?
Yes.
Yeah. So when you run, okay, when you type in run ncpa.cpl, so what will open up when you type that ncpa?
When you type this ncpa.cpl, this network connections window will open.
Okay.
Okay, where you can
Mm-hmm.
see the network adapter. So if you get this network
Yeah.
adapter means network drivers are loaded. You need to right click on this network adapter,
Uh-huh.
click on properties.
Mm-hmm.
We have to select TCP IPv4 and then again click
Mm-hmm.
on properties. Okay, select TCP IPv4,
Yeah.
click on
Mm-hmm.
properties.
Mm-hmm.
So here it will be obtain IP address automatically and obtain DNS error automatically. We have to select
Oh yeah.
use the following IP address
Yep.
and what are the IP address you want to assign.
Mm-hmm.
You press tab, automatically IP address will come. Sorry, subnet mask will appear.
Yep.
Click on OK.
Mm-hmm.
Click on close.
Yep.
So we have assigned IP address for the system.
Mm-hmm.
Now to check IP address from command prompt,
Mm-hmm.
Windows R, type CMD.
Oh yeah.
Enter. IP config.
Yep.
Type IP config,
Mm-hmm.
which gives the IP address assigned to this system.
Oh yeah. Hmm.
IP config /all along with IP address, you'll be also getting the DHCP, DNS, lease period if you're having, and the MAC
Mm-hmm.
address.
Yep. So in this, where you will choose the MAC address?
Yeah, I will show.
Yep. Oh, it's coming up with media disconnected. Okay. But usually when we log into the laptop, it will comes up. Like if we give ipconfig/all,
Hmm.
like see channel adapter ISC or something. So it
Hmm.
all comes up with the physical address,
Yes, the
but it's
physical
not
address.
there in the remaining one. Yeah. But if you do ipconfig/all in the normal laptop, it
Hmm.
will comes up for. I mean, not only for Ethernet adapter, it also comes up for the other state like channel adapter or whatever
Yes,
it comes
yes.
up at the bottom.
Here also
For
we have
everything, it's
physical
coming up
address.
with the physical address. Yeah.
We need
So
to
at that
see
time,
for
how can
Ethernet
you
adapter.
choose?
We have to see for Ethernet adapter.
Okay.
We have to ignore the
Ah,
remaining
okay,
things.
okay. Mm-hmm.
Okay.
Okay.
And here we are having this DNS addresses. This FEC0, this is IPv6 address.
Yeah.
The
Okay.
default address assigned, it's a IPv6 address.
Mm-hmm. Okay.
FE80,
Okay.
if any IPv6 address is starting with FE80, it means it is a link local
Mm-hmm.
IPv6 address.
Link local
Yes.
IP address. Okay.
Now, if I
Uh-huh.
want to get only the MAC address, I don't want
Mm-hmm.
all this stuff. I want only MAC address. Then
Uh-huh.
I need to type get MAC. Enter.
Ah, okay. Okay. So it will give just the MAC address. It's a bit slow.
Yes. It's because of three things. We're having
Mm-hmm.
this recording. It's occupying some memory.
Mm-hmm.
We're having this virtual machines. It's also occupying this memory.
Mm-hmm.
Okay. So we get only MAC address.
Ah, okay, okay. Yep, got it.
Okay. To check
Yep.
the connectivity between devices, we need to use ping command, ping
Mm-hmm.
space,
Yep.
IP address.
Get a
Actually,
name.
here we need
Oh
to
yeah.
use the other device's IP address
Mm-hmm.
to which system you want to connect. If you're getting
Mm-hmm.
reply,
Yep.
means you're
Yep.
having connectivity.
Then you can able to ping it. Yep. Yep.
When we
Yep.
have the issue,
Mm-hmm.
even though we are having the same network IP address for both the devices, still we are not able to
Mm-hmm.
get the connectivity. Even though we had checked the physical connectivity between devices and it is perfectly all right, but still we are unable to communicate. Then we
Mm-hmm.
do the self pinging.
Ah, okay.
Now, when we do the self pinging, if we are not getting reply from our adapter, it means
Mm-hmm.
there is some problem with the IP address assigned to our adapter.
Yeah.
Again, we need to remove the IP address and reconfigure the IP address and again do the self pinging. If you get the
Ah, okay.
same problem, then
Mm-hmm.
last and final step we do is this loopback adapter 1.x.x.x 0.0.1. If you're
So
getting,
what's this IP address?
it's a loopback adapter IP address.
Loopback. Okay. Yep.
Initially it is 127.0.0.1 only, but later they had taken
Mm-hmm.
all the 127.network as loopback adapter address.
Ah, okay.
So
Yep.
if we are getting reply from this, it means you're not having any problem with your slot, or you're not having any problem with your adapter. But there is some logical problem with taking the IP address by the adapter, which we need to try to resolve. But if you are not
Yeah.
getting reply from this loopback adapter also, it means your adapter, network adapter, is not functioning properly, or the slot in which this
Okay.
external network adapter is inserted, the slot is having some problem.
Okay.
So this is the basic
Yep.
troubleshooting in checking the connectivity.
Yep. Yep.
Okay, ping stands for packet internet grouper.
Yep.
Okay, packet internet grouper. Okay, we'll continue
Mm-hmm.
tomorrow at same time.
Yeah. Sure. No problem.
Okay,
Yep.
and your
Sure.
Thank you.
recordings, you'll
Uh-huh.
getting the recordings tomorrow morning.
No problem.
Okay. No worries then.
Okay,
Yeah.
Thank you. Thanks for your time.
okay.
Thank you. Yep.